Hi again guys, Bioinformatics guy here with another video of the series Python for Bioinformatics. In this video, we will be talking about Python functions and how you can define your own functions in Python. So let's get started. Just recall the functions that you have studied during college level math. Python functions are just like math functions that we have already studied. Most of us are familiar with those math functions, but for those who are not familiar with them, let me explain it with a simple example of this guy John. Being a human being, John can perform several functions, but we will be focusing on only one function, and that is John can eat pizza, then it does some processing in the body, it discards the byproduct, and the end result is it gets energy to work. If we compare this with the function in Python, we can see that a Python function eats parameters, which is pizza in John's case, does some processing in the body, discards the byproducts, and get us the results, which was energy in John's case. As we have a better understanding of Python functions now, and we are already familiar with how to use Python functions as we have been using length function, the count function, and so on. Now we are going to learn how we can define our own functions in Python. Before we start, there is one more thing that I need to tell you. So far we have been working in Python shell, and in Python shell, as soon as we hit enter after writing some code, it executes it. But defining function is a multi-line thing, and we will have to use something else, and that is Python files. So if you are using Windows and you are using the basic Python idle, you can create new Python files just like that. So go click over here, file, new file, and then it creates new file. You can write print hello to the bioinformatics world. Alright, and in order to run this code, you will have to press F5, and then you have to save this file for the first time. When you will be running it for the second time, you won't be prompted to save it again. So you can save it anywhere. Let's save it in the desktop. On the desktop, where is our desktop? Here's the desktop, and I'm gonna name this file Python functions. You can see that now our statement is printed in the Python shell. But for the sake of this series, I'm gonna be using Google Colab files. Google Colab is another Python Jupyter notebook, and you can also work in Google Colab. If you don't know how to create a Google Colab and how to work in Google Colabs, you can check out the first video of this series in which I have described everything in detail. So I have already opened a Google Colab file. So let's see how we define functions in Python. So in Python, new functions are defined by definition statement. Definitions are compound statement, means that they contain more than one line. We will start by the keyword def, and then we have to write down the name of the function. I'm gonna write over here name. Then we have to add a pair of brackets, and in this pair of brackets we have parameters. Parameter 1. If we have multiple parameters, we can separate them by commas, parameter 2, so on and so forth. After the brackets, this sign goes, colon. And once you have written this line, then you have to hit enter and go to the next line. In the next line comes the body of the function. Now you need to keep this in mind that every statement of the body of the function is supposed to be at least 4 spaces indented. When you will hit enter after adding the colon sign, the new line will automatically be indented by 4 spaces. Now this function is not gonna work. This was just for the sake of explanation. So let's define one of the basic and the simplest function that is possible in Python. So we will be writing the same keyword def, then the name of the function could be fn, then we have the pair of brackets. One more thing, you can define a function without parameters. So if we have to do that, we just keep the pair of brackets empty, and then we will write over here pass. So this is a working function which does nothing. funny. So I'm gonna explain simple and basic Python statements that are used in functions. First statement is return statement. We use this statement when we need an output from the function. You have calculated something in the body of the function and you want to get the result as answer of the function, then you will be using the return statement. So the second statement is the pass statement. It does only one very specific thing, and that is it does nothing. You put the pass statement when you don't know what you're gonna write over here, and you put it as a placeholder. Now let's define a function that does something useful. And we will be defining this function that will validate our base DNA base sequence. So we will be starting with the same keyword def, then comes the name of the functions, which could be validate base sequence. And in the parameters we will be needing the base sequence, so base sequence. Here comes the body of the function. So we will have our base sequence. It could be capitalized and it could be in small alphabets. We have to change it to uppercase, and we can do it simply by base c dot upper function. Then we have to check whether the length of the function is equals to the sum of the a's, t's, g's and c. And we can do it simply in Python by just checking the length of the sequence by this len function, and then we have to see whether it's equals to. So we will use double equals to sign. Then we have to add the counts of a, t and g and c's. So first let's count a, then we have to add, let me copy a, let's put a t over here, let's put a g over here, then we have to add the last one, which is c. So this is too long, let me reduce the size a little bit. A, T, G, C. So we are adding and then we are checking, and if we run this, nothing will happen, but the function will be defined in Python and it will be stored in Python library. So this is quite a long line and it's a bit difficult to read, so we can use these extra pair of brackets, and then we can go to the next line, and you can see, let's align this. All right, and then go to the next line, then align this, and then finally put the closing bracket. Now you can define this function by running this code, and this function is finally saved in the Python library. And let's try using this function. Alright, we can use this print statement and it gives us true, but if we will add something like I over here, which is not included in the basis, so then we are supposed to get false, and we are getting false, so our function is really working nice. So before moving on, let's talk about function parameters. The function that we just created, validate a DNA based sequence, has only one parameter. But there could be functions which can have more than one parameter. So what are function parameters? So in Python, whenever a function is called, it assigns the value of the first parameter to the first argument. Then it assigns the value of the second parameter to the second argument, and it goes on. So let's define a function that is gonna be using two parameters, and this could be the function that recognizes the binding sites in the DNA. You must be familiar what is a binding site. Binding sites are small chunks of DNA or DNA bases at which several enzymes and replicators attach, and then they start to replicate the DNA. We will start with this keyword def, and the name of the function could be recognition site. Now we will have to give it a base sequence as well as the recognition sequence. Then a colon, then hit enter to go to the next line. After that, here comes the body of the function, and it's gonna contain only one line, return. And what we need to return is, we can use this function find base seek dot find, and then we have to find our recognition site, and we can copy this and put it here, and our function is ready. So you have to write down the spellings of the return correctly. Alright, now you can run this again, and our function is defined. Now let's try and call this function. You can print, this is gonna be our base sequence, and our recognition side could be simply triple C's. Yeah, let's run this. You can see that it is outputting the place where this thing starts. Since you have started to work in Python files now, you will be writing several lines of code. When you will save a Python file and you will open that file after a few months or so, it won't make much sense to you because it's in human nature that we tend to forget things. If you are so confident enough that you won't forget anything even after months, let me tell you another perspective of the same problem. Once you learn basics of Python in this series, you will be capable enough to work on bigger projects, and you will have to work on teams. So if one of the team member reads your code and the code is not making much sense to that person, so this is going to be quite difficult to work in a team. Comments and documentation comes in handy to help us in this problem. So comments are just brief explanations of the lines of code that you have written, so that later on any team member or even you can read the comments and find out what this code is all about. The simplest way to add a comment in Python is by using this hash symbol before that comment. So whenever Python sees a hash symbol, it ignores everything that is written after that symbol in that specific line. So let's try writing a few comments for our function validate base sequence. So the first comment could be a short example explaining various details of Python function definitions. The next line could be representing a base sequence return true or false according to the composition of the string, entirely of upper or lowercase a, t, g, and c characters. And then we can add few lines like argument should be a string. Then we can add something like ensure all the characters are uppercase. So that is the brief explanation of the function. So once you will save this file, and later on if you will open this file after a few months, if this code is not making much sense to you, you will be able to read the comments and find out what is this all about. There is one problem that we have to face over here. The first is that we have to type hash in every new line. Moreover, if we are writing very long lines, it is difficult to read that code. We have to scroll over here. So that is why it is a general Python convention that your code should not be longer than 79 characters. And this Google Colab is showing us this line that whenever you will pass through this line, your character will be 80th, and you don't go past this line. And you can see that over here we are going past this line. So to cope up with this problem, we have docstring. Synthetically, docstring is just a basic string which stars the definition of the function. So let's try adding a docstring comment in our function. Let's add a new block of code over here, and then let's remove these all strings. Let's add a docstring. So in order to add a docstring, you will have to use triple quotes, 1 2 3 and 1 2 3. Now in these triple quotes, you can write anything and that won't be executed in Python. It will be considered as a comment. So a really nice docstring for this function could be return true if the string basic contains only upper or lower case a, t, gc characters, otherwise false. Now we can run this function and see it just executes. Technically the docstring and the comments are not making any difference to the function. These are just helping comments for us. So there is slight difference between docstring and simple hash comments. So comments disappear whenever we run the code, but docstrings are retained. Consequently, docstrings have a greater utility than comments. In particular, the help function that we use to know about things in Python looks for the doc string that is defined by the user as well as the parameters of the function to generate the help description. So let's try using help function on our own find function. Help, and then we have to write down the name of our function, which is validate base sequence. Let's run this code and see what happens. Now in the description, let me make it a little bigger. So you can read our docstring over here, and you can also see the parameters and the name of the function. Let's look at another example of Python function. So genomes of various species and the regions within a genome vary with respect to the content of G's and C's as opposed to the T's and A's present in the DNA. So it is a straightforward practice to calculate the GC content of any DNA based sequence. Now we need to define a function in Python that will calculate the GC content of a given DNA string. One of the advantages of the interactive environment such as Python is that you can experiment with the small bits and pieces of code before you can put them together to make a big function. So here is a small example of that experimentation. Let's see how many C's are there in the sequence. C.count C, there are 3 C's, and C.count G, there are 4 G's. Let's see that what is the length of this sequence. Length is 16. Now we know that in order to calculate the GC content, we need to add the number of G's and C's and then divide them with this whole length of the sequence. Let's add C's plus C.count G. Let's close this bracket, then divide this whole thing by length of the sequence and hit enter. You got your GC content. Alright, so let's put them together and make a function. You can even copy these statements. So we are gonna write GC content, CLCULATOR. Okay, so def GC content, and then we can write base seek. Then we have to add a doc string, and in the doc string we can simply type return the of G and C's in the base. Now the rest is very simple. Let's convert it into uppercase, and then we just have to copy this line and return it. Okay, let's make it bigger so that we can read what's going on over here. And that's pretty much it. Our function is ready. Let's run this so that this function is stored. A meaningful example to use this function will be when we will have a long stretch of DNA string. Then it will be difficult to tell whether the result was correct or not. So when writing functions, it is a good practice to have small test cases whose answers are already known to check out our function is working properly or not. So I have already created some test cases. Let's run these and see if we get the correct answers. Print GC content C50, then we can print GC content of C75, then we can of C40. You can see that we got 0, 0, 0, which is not the correct answer, and we have to find out what is the problem over here. We can see that over here it's written small c, however in over here we are changing it to the upper letter, so we will have to make this capital. Let's rerun this and then run this again, and we can see that we got the correct answers. 0.5, 0.75 and 0.4. So now we know how to define Python functions, as well as we have also learned how to document those functions. So before we move ahead, there is one more thing that we need to consider learning, and that is assertions. While developing code, it often happens that your function is called with arguments of wrong type or value. Depending on the details of the code, an invalid argument may result in an error or a nonsensical result. Even worse, it might result in apparently meaningful but incorrect result. For example, the definition of GC content assumes that the given string contains only G, C's, A's and T's. Since we are only counting G's and C's, all of the other characters are assumed to be A's and T's. So if a given string contains a few invalid characters, it will return a value that will make sense, but it will be off by a little amount. So before we move ahead, there is one more thing that we need to consider learning, and that is assertion. It is always a good idea to express the function's assumptions in the docstring. However, the documentation doesn't have any effect on the computation. Documentation can stop anyone from calling a function with invalid argument. Nothing stops someone from calling a function that violates the documented assumptions. To ensure compliance, Python provides simple assertion statements to ensure that the function is called with correct arguments. So a single assertion statement could be assert 1 equals to 2. When you will run this, you will get this assertion error. We will soon see how we can use this in the function. Before that, let's see what is a two expression assertion. So let's try this out. So assert 1 equals to 2, and if this is wrong, then we can give this error invalid arguments. Now when you will run this code, you will see that it also tells us that you got this assertion error because there are invalid arguments. Alright, so let's improve GC content by ensuring that its arguments is a valid sequence string. We already have a function that does what we need, validate base sequence. We will add an assertion statement that calls that function. Alright, now we need to modify this function. Now we simply have to add this line over here, assert validate base sequence. Then we have to enter base sequence over here, comma. The next argument is, I'm using this slash to go to the next line. This slash tells us that the code is continued, and we can type argument has invalid correct. Now we can simply run this. Then we can run these. We got the correct answer. Now if I will add something wrong over here, let's say then I should get an error. You can see that I got this assertion error in this statement, and you can see that it is saying that argument has invalid characters. And you know, if we comment out this line and define this function again and run this again with this wrong value, you will get the result, which is wrong. So this is benefit of placing assert statements in our functions. Now you have seen that in the last example, one function calls another function. It is a common practice in Python. Now each function should perform what is conceptually a single coherent action. This means that you will write relatively small functions that will call each other rather than writing a function with multiple steps. Now you can think of functions as building up vocabulary. In defining a vocabulary, it is natural to define some of its words in terms of others. Python provides a small initial set of definitions, and you can expand on that set by defining more of them. One reason for writing small functions is that simple functions are easier to write and test than complicated ones. If a function A calls B and B calls C and C calls D, but something is not working in D, you can call D yourself from the interpreter. Once you are sure that D works, you can call C, and so on. Writing small functions also helps us to avoid code duplication. That is, having a group of statements repeated in more than one definition. Code duplication is bad because if you want to change those statements, you will have to find every definition that uses them and spend considerable time making the same changes in each definition. Alright, now we also know the importance of writing small functions. Let's move on to the next topic, which is default parameter values. You often find that most calls to a certain functions are likely to include the same value for a particular parameter. Frequently, this is a value for something simple such as true or none or 0. In such cases, Python provides a way to assign a default value to the parameter that will be used if no explicit value is included in call to that function. If you have explored built-in functions with the help function that I told you earlier, you might have come across this fact that some parameters of functions are optional. The Python definition designates an optional parameter by assigning it a default value in the parameter list. Let's make validate base sequence more flexible by giving it the ability to handle RNA sequences. Let's add a second parameter whose value determines whether the function looks for T's or U's. We call our new parameter RNA flag. Let's edit our function validate base sequence, and we need to add RNA flag over here, flag. And we will also have to modify the documentation Return true if the string base sequence contains only upper or lower case A's, T's or U if RNA flag. Now we also have to modify the return statement. Sequence count U if RNA flag else T. Now this line will count U's if RNA flag is true. Now let's try this with small chunk of DNA ATCG. If we turn the RNA flag as false, then we should get true result. If we turn the RNA flag true, it should give us false because this is a DNA sequence. Now if we change this T to U, then we are supposed to get true because now this is an RNA sequence. Okay, so we were talking about the default parameters. In order to make this RNA flag a default parameter, we will have to give a predefined value over here in the definition of the function, and a good thing is to give it a false value because most of the times we will be validating the DNA sequences. Now if we will call this function with just one argument, then it will assume that we are providing it a DNA sequence and it will calculate the things accordingly. Okay, we have to rerun this function and then we have to rerun this. Now we got the true answer, and if we want to run this for RNA, we will have to change it to true. Now this is checking that whether it's an RNA sequence or not. Alright, so that's pretty much it for today. In the next video, we will be talking about using modules in Python. If you have any questions, comments or concerns about this video, you can always comment down below. I will be happy to help you out. And if you want to know what I do other than programming, you can check out my vlogging channel right over here. Thank you very much for watching, and I will see you around in the next video.